This is something I've never really done before. This is interesting. So I want to talk about this. Which graph in 5.21 can you use to determine how many times faster the record supercomputer speed was in 2000 than in 1970? Use your answer to comment more generally on when exponential scales are useful. So, I've always taught whenever you do your y-axis, you have to go up by the same amount each time. Well, notice this goes up by, instead of going up by adding a number, it's basically multiplying a number each time. You're multiplying by 10 each time. Instead of adding 10 each time, you're multiplying by 10. Now, this one goes up by a set amount. Now, the problem here with this, though, is that these values are so small, and we have an exponential growth here, a huge exponential growth here, and we aren't able to see kind of the growth in this area. The growth in this area is very much minimized, and so in this case, in the 5.21, if you want to determine how much time faster the speed was in 1970, I would say figure 5.21a. That one's A. This one's B. Your 5.21a allows you to more, because on this one you could actually find the values and then you just have to divide at the end more easily. Find how much faster the record computer speed was in 2000 than in 1970. Okay, because you could clearly get a value for 2000 or get a good estimate, and then you can get a value for 1970. So 1970, it was around 10. So 1970 is around 10. 2000, it looks like it's around maybe 10 million. Maybe 10 million. And so then you could just divide those 10 million. We've done this before, divided by 10. Okay. So 10 million divided by 10, that'd be a million. So it'd be a million times faster. So whereas on this other one, you wouldn't be able to get a value. You couldn't get a value for 1970 or 2000. That you can't see how big of a gap that is. Okay. And so exponential scales are useful whenever data vary over a huge range of values. So exponential scales, as I said, I have never used an exponential scale on a graph. Okay, so you can do something, learn something new. Are useful, whoops, I can't spell. Are useful when you whenever data vary over a huge range of values. Okay, so like here, you see there's a huge range of values there versus, and so you can see that gap a lot easier.